Now there are certain quantities: velocity, displacement, distance, acceleration. So we have to require the relation between them. Those are called equations of motion. So let us discuss about equation of motion. Equation of motion. What are those? Number 1, V equal to U plus AT. What is V? V is final velocity. U is initial velocity. A is acceleration. T is time. So this is the first equation which relate V, U, A and T. Number 2, S equal to UT plus half AT square, where S is the displacement or the distance. Look, those equations are for body having constant acceleration. This is not for the retardation. This is for the accelerated body, not the retarded body. Now the third one, which is the important one, V square equal to U square plus 2AS. Mind it, those equations are for accelerated motion. For the retarded motion, the equation should be like that. Equation of motion for retardation. Equation of motion retardation gives you that plus sign should be altered by a negative one. If we draw this equation, V equal to U minus AT, S equal to UT minus half AT square, V square equal to U square minus 2S, then those equations are the equation of motion for the retardation. So first quantity, which is V equal to U plus AT or S equal to UT plus half AT square or V square equal to U square plus 2S, those equations are the body's equation which are constant accelerated motion. But whenever we draw this equation, V equal to U minus AT, S equal to UT minus half AT square, V square equal to U square minus 2AS, then those equations are for retarded motion. Now we have to derive those equations by graphical analysis. So equation of motion, derivation of equation of motion by graphical method. Now for these equations we have to draw the velocity time graph, and we deal with the accelerated motion. We deal with this for accelerated motion. So velocity time graph for accelerated motion. Now if we draw this kind of straight line which is starting from that point, take this O as origin and this point is the initial point. So the body's movement is with a certain kind of velocity, or it is in an initial velocity, that is U. Now after time interval T, that the body moving at that point and take at point B, the body's motion is in the form of C and the velocity at that point is Vc. So at initial moment, whenever t equal to 0, the initial velocity should be OA, and for after time interval t, the final velocity the body reaches is capital small v. Now if we draw the slope of that curve, now if we draw a right angle triangle, this is a right angle triangle and this cutting point referred as E. So from that graph, that triangle ACE, for triangle ACE, the slope of that curve, slope is nothing but height by base, and the height is should be like that, CE by AE, because AE is the base. Now CE is nothing but BC minus BE. and AE is nothing but OB. Now BC, this BC is subdivided. VC is nothing but V, the final velocity, so it is V. BE, BE is nothing but OA because these two distances are same. So OA is nothing but U, so V minus U, and OB is nothing but T. And the slope of that velocity time graph, previously we know that the slope of the velocity time graph gives you the amount of acceleration, so slope is A. Now from that, AT equal to V minus U, and that would give V equal to U plus AT, and this is the first equation. So this is the first equation which look like V equal to U plus AT. Mind it, this equation is derived for a body's motion which is at a form of constant acceleration. Constant acceleration. But it is, if it is in a constant retardation, then graph should be like that. Because the velocity is decreases with respect to time, and if the velocity is decreases with respect to time, that would give the amount of retardation. For the retarded motion, the equation should be like that, V equal to U minus AT, but the graph should be like that. Now the second equation, which is S equal to UT plus half AT square. Again we have to draw the velocity time graph. Mind it, for every equation we have to draw the same graph, velocity time. There is no any other graph. We have to draw the velocity time graph. The equation should be different by the formation of equation, but the graph should be same. So velocity time. Again the body starting not from the initial velocity which is 0, but with a certain velocity which is U, because we have to draw the general equation. So at that point it is A, it is O, it is C, it is B. Now that point OB is T and OA is U, BC is V. So this is the final velocity, this is the initial velocity, this is the time. At that time the velocity reaches from U to V. Now if we draw or if we calculate the distance from this graph, we have to draw or we have to calculate the area under the graph. That means this area. Now it looks like a trapezium, and also it is a trapezium. So for the trapezium, the area of a trapezium, this looks like that, more or less, and the area of trapezium AOBC, that gives you the amount of displacement, which is S. Why? Because in previous previous lesson we have learned about that the area under the velocity time graph gives you the displacement. So S, which is nothing but area of AOBC. Now the area of a trapezium is equal to half into sum of the parallel side into the perpendicular distance between those parallel sides. Mind it, for area of the trapezium is nothing but sum half into sum of the parallel side, sum of parallel side into height or perpendicular distance between two parallel sides. So in this equation, half into sum of the parallel side is like that, OA plus BC, and perpendicular distance is nothing but OB. So half into OA, OA is nothing but U, and BC is nothing but V. OB is nothing but T. So half into U plus. Now from the previous equation derivation we have to know that V is nothing but U plus AT. So put this value here, U plus AT into T. That would give half into 2U plus AT into T. And finally, that result come half into 2u, that gives you u plus half into a into t square, that means half at square, half into 2u into t, that would give half into 2, that cancels out, and u into t, that means ut. Now half into at into t, that would give half a t square. Now the third equation, which is the last equation of this chapter, which is like that, v square equal to u square plus 2s. Now again we have to draw velocity time graph. Velocity time graph. Now this is the initial position, the body starts from this and it is moving along this direction. So it is a position, and at the time interval it is in c. Now this is the total position time graph, the velocity time graph. Now if we draw this thing, it is in position e. Now this CV is nothing but v, OA is nothing but u. So from this graph we have to draw S, area of the trapezium, which is AOCV, and it is nothing but half into OA plus BC into OB. And the value of acceleration is like that, the slope of the curve, which is CE by AE. Now CE is nothing but BC minus EB by AE is nothing but OB. BC is BC, it is fixed. EB is nothing but OA by OB. So this is the equation number 1 and this is number equation 2. Now if we multiply this equation number 1 with equation number 2, this looks like A into S, that is half into OA plus BC into OB into BC minus OA by OB. Now this OB cancel out. Now BC plus OA, BC minus OA, that would give BC square minus OA square. So it is like that, half into BC square minus OA square. Now half into BC square is nothing but V square and OA square is nothing but U square. So AS is like that, or AS 2AS equal to V square minus U square, or V square equal to U square plus 2AS. So this is the final equation of this chapter, and hence chapter closed.